I'm going to start introducing you to the clawbot. The other day I showed you a sample pick-and-place program to kind of get started with, so that when you got to the clawbot activity, you'd be used to programming a couple of drive motors and the claw motor. And I know a lot of students had gotten to that point just the other day, and so I'm getting ready to move on with this next activity. Now, you can see I have the clawbot sitting on the floor. I was running out of room on my table, and so I had to get a little bit creative to get it to show in my camera area. Now, some of the clawbots on the shelves do not have a cortex on them. The cortexes had been removed in case they were needed for test beds, or in case they were needed for some other building projects that I was thinking about doing. So if you're starting this activity and you're getting a clawbot that does not have the cortex to wire your motors and sensors into, then you're going to have to find a cortex. Either there's a tray with some cortexes still in them, or you can take one off the test bed if we've finished up with those. Now, before I get too in-depth with the clawbot, I want to go over to an example of a Robot C program that I got going on. This was a program that I've worked on over the summer with some students that I was teaching in another class. And this is a basic pick-and-place activity. It starts with a push button. I have the arm motor move, and then I have the claw move. I have the clawbot drive in a straight line. I have it stop. I have the arm come back down, and the claw open. And really, I can't remember what this program does until I download it, which I haven't done yet because I was getting the clawbot ready. But what I want to point you to is when you do get a clawbot, you have to look at things in your motors and sensor setup. Now, I have my right motor and my left motor in ports 1 and 10, like I've done in the past. But on this setup, I have the claw motor in port 6 and the arm motor in port 7. Now, when we go to program both the claw and the arm, we have to understand that there's going to be limitations. That means if we over-program them, we're going to strain the mechanical systems, not only the motors, but the batteries as well. So we want to make sure that we're using a pretty slow speed and a pretty slow wait time. I have no analog sensors set up on this. I just have a push button. The purpose of the push button is so that I can start the program without it being tethered to the computer. If I went to download the program and then I hit start on the desktop, the machine's going to take right off. So the push button's more or less a safeguard to get things going. And then for digital sensors, I just have one push button. It is in digital port 2 on the Cortex, and it's a touch. You can have it in port 1. You can really have it in any of those digital ports as long as you have it set up right in motors and sensor setup. Let's take a moment to look at the clawbot mechanically. So bear with me as I get this up here. I have the Cortex. It's sitting there in the middle. If I carefully lift up the arm, you can see what's going on here. If I can get that in the right view, there you can see the two motor controllers. They're coming out of the motor ports. Those are those pigtails. They take a 2-wire object and they turn it into a 3-wire. There's a better view. And I have those in ports 6 and 7. You can kind of see that I have my drive motors in ports 1 and 10. And you can also see that I have my digital sensor in port 2. If you look at one of the wheel trains, it's set up with a simple gear train. The motor is actually actuating the idler pulley, and it's creating 2 drive pulleys. Since the idler pulley's sitting in the middle there, the 2 drive pulleys will go in the same direction. Now, since we have motors on both sides, I'm really having a tough time with this camera, but since we have motors on both sides, this side as well, this is essentially, it's a four-wheel drive vehicle, but if we reverse our drive motors, then it will be able to create a turn. And I'm hoping to show you that here in a moment. So I'm going to download this program that I have on the computer. Make sure my battery's not in a bad spot. There. Sorry about that. I'm going to hook up my orange cord. Turn my Cortex on. We're going to go back to Robot C now. This is all okay. So I'm going to do a firmware download to clean out that Cortex. And this takes longer than the program download. You're probably used to this by now, I'm hoping. And then we're going to do a download to robot. All right, we're going to click our start button, and then we're going to go back to our robot. So we're going to unhook the USB. And let's see if I can set up a video to okay, so the arm is raising. We're doing the drive forward. Claw opens. Goes down as if it's going to emulate picking up something. Closes. Turns with the object. There you can see my point turn goes way too far, so I have some work to do. I really want that to be at about 90 degrees. And there it emulates dropping the object off. So that's just an example to get started with. Now if you go back to my program here, we can look and see where we're going to identify some of the changes we're going to make. Now over the next few days, I'm going to give you some different programming tasks to do with the clawbot, and having your program set up similar to this one that I'm presenting to you today will be useful in looking at solving those tasks that I give to you. So very similar to the template that you use for your test bed, you're going to have to add a couple of more motors. You're already used to the claw motor, but you're also going to have to add the arm motor. You're not going to be working with the test beds on this project. Once you've done that test bed practice project, you're going to be ready to move on to this clawbot and try a sample program. So until next time, good luck.